every campfire you've ever built has been lying to you. Not a little, completely. That warm glow you trust, the crackling flames, the smoke drifting slowly into the night sky. It feels right. It feels efficient. It feels like you're doing exactly what humans have done for thousands of years. But here's the reality. That fire is wasting more energy than it's giving you. And once you see why, you won't be able to unsee it. Let's start with something simple. Watch your next campfire closely. Not the flames, the smoke. That thick gray cloud rising off the wood, curling upward, disappearing into the air. Most people think that's just a byproduct, pollution, annoying maybe, but harmless to the fire itself. That assumption is the first mistake, because that smoke, that is fuel, real fuel, energy that you already paid for with time, effort, and firewood, and your fire's just letting it go. Here's what's actually happening inside that log. Before wood burns, it doesn't just catch fire instantly. It goes through a process called pyrolysis. Heat breaks down the structure of the wood, the cellulose, the fibers, and it releases gases, invisible at first, then visible as smoke. Those gases aren't weak, they're packed with energy, methane, hydrogen, organic vapors, and together, they hold about 60% of the total energy in the wood. Think about that for a second. More than half the energy isn't in the flames you see, it's in the smoke you ignore. Now here's the problem. Those gases don't ignite easily. They need high heat, around 600 degrees Celsius just to start burning, and closer to 850 degrees Celsius to burn completely. Your average campfire, it doesn't get there, not consistently, not where it matters. At the edges of the fire, where the smoke actually exists, temperatures often sit around 300 to 400 degrees Celsius. Too low, way too low. So what happens? Those gases rise, cool slightly, and escape before they ever ignite. That smoke you're watching drift into the sky, that's energy leaving your fire, unused. And here's the part most people get wrong. When the fire feels weak, when it's not giving enough heat, what do? You add more wood, bigger logs, more fuel. It feels logical, but all you're doing, that is feeding the same broken system. You're increasing the amount of fuel being wasted, not fixing the reason it's being wasted. So the fire gets bigger, the flames look stronger, but the efficiency, still terrible. Most open campfires operate at around 10 to 15% efficiency. That means up to 90% of the energy is lost, radiating away, or worse, floating away as smoke. So here's the real question. What if the problem isn't the fuel? What if it's the design? Because there's a completely different way to build fire, one that doesn't rely on size, but on control. Instead of letting heat escape in every direction, you trap it. Instead of letting gases drift away, you force them through the hottest part of the fire. Instead of a wide open flame, you create a focused path. This is where things start to change. Imagine a vertical column, narrow, enclosed. As the fire burns at the bottom, hot air rises upward, fast. That rising air creates a pressure drop below, and that pressure drop pulls fresh oxygen into the system. No fan, no blowing, no effort. And here's where it becomes powerful. The hotter the column gets, the faster the air moves. The faster the air moves, the more oxygen feeds the fire. The more oxygen feeds the fire, the hotter it gets. Instead of letting heat escape in every direction, you trap it. Instead of letting gases drift away, you force them through the hottest part of the fire. Instead of a wide open flame, you create a focused path. This is where things start to change. Imagine a vertical column, narrow, enclosed. As the fire burns at the bottom, hot air rises upward, fast. That rising air creates a pressure drop below, and that pressure drop pulls fresh oxygen into the system. No fan, no blowing, no effort. And here's where it becomes powerful. The hotter the column gets, the faster the air moves. The faster the air moves, the more oxygen feeds the fire. The more oxygen feeds the fire, the hotter it gets. It's a loop, a self-reinforcing system. Now add one critical detail: insulation. In a normal campfire, heat escapes outward in every direction. You only feel the small fraction that reaches you. Everything else is gone. But inside an insulated system, that heat gets trapped, reflected back inward, roast. Temperatures climb higher and higher and higher until something important happens. Those gases, the ones that used to escape as smoke, can't escape anymore. They're forced upward through the hottest part of the system, and when they hit that temperature threshold, they ignite. The smoke catches fire. That's secondary combustion, and it changes everything. Now you're not just burning wood, you're burning the gases released from the wood, the part that used to be wasted. This is why these systems can reach 35 to over 50% efficiency, 3 to 5 times better than an open fire. And in real terms, a small handful of sticks can produce the same cooking heat as an entire pile of logs in a traditional campfire. Same fuel, completely different outcome. Now here's what makes this even more interesting, because this idea isn't new. Long before modern engineering, people had already figured this out. There's a fire design that looks almost too simple to matter. 2 holes in the ground. One is the fire chamber. The other is an air intake. A small tunnel connects them underground. When the fire burns, hot air rises out of the main hole. That creates a pressure drop, and that pressure pulls fresh oxygen through the second hole, directly into the base of the fire. You've just created a natural airflow system. The fire burns hotter, cleaner, more controlled. And because the combustion is more complete, there's far less smoke. Even better, wind doesn't ruin it, it improves it. Wind passing over the air intake increases the pressure difference, forcing even more oxygen into the system. While a normal campfire gets blown sideways, this design gets stronger. So let me ask you something. What's actually powering both of these systems? Is it the wood, the shape, the wind, or is it something simpler? It's rising hot air, creating a pressure difference, pulling oxygen exactly where it's needed. That's it. That's the core principle. And once you understand that, everything about fire starts to look different, because now you realize a good fire isn't about how big it is. It's about how well it burns its fuel. So the next time you build one, change a few things. Use smaller sticks instead of large logs. Feed the fire gradually instead of dumping everything in at once. Let airflow move through the structure, not around it. Keep the heat concentrated instead of spread out. Even something as simple as placing rocks or logs behind your fire can reflect heat back towards you instead of letting it disappear into the night. Now you're not just sitting next to a fire, you're sitting inside a system that's actually using its energy. And once you see that, it becomes impossible to ignore. Every campfire you've ever built was throwing away more than half its heat. Not because you didn't try hard enough, not because you didn't add enough wood, but because nobody told you what fire is really doing. It's not just flames, it's not just heat, it's physics, it's airflow, it's invisible fuel rising right past your face while you reach down for another log. Now you know what that smoke really is, and more importantly, you know how to burn it.